What we have, this is a video for instructional purposes only. What we have here is a NOR, a gate logic system. We will start right here with a 5-volt battery, 1K ohm resistor, switch B, switch A, and a lamp. The switches are wired in parallel with each other. Right now, as you see it, electron flow goes through the lamp, and this is a on state. Once one of the switches closes, it shorts the lamp out and the lamp will turn off. It's either an A or the B. Either the A switch or the B switch. That'll turn off the lamp. This right here is the logic symbology of a NOR gate. Basically, it's an OR with a little dimple at the end, making it into a NOR gate, similar to this. An OR gate with an inverter. The A is for the A switch. The B is for the B switch. This is the truth table. We'll use this illustration to help clarify. When A is not pressed and B is not pressed, you get continuity flow through, so you get a 1 on the Y. When A is not pressed, B is pressed, you get no continuity flow through the Y. Right here, when A is pressed, B is not pressed, get no continuity flow going through. Basically cuts it off. But when you get A is pressed and B is pressed, you get no continuity flow going through. So it's only when you don't press either one, you do get continuity flow going through. This right here is an integrated circuit chip. The chip is a 7402 quad input NOR gate. Pin number 2 would be for the A switch. Pin number 3 would be for the B switch. Pin number 1 would be the output, or the Y. Similar to what we have here. This is the A switch, this is the B switch. Let's hook this up. Like it's shown here, the lamp is on because it's going all the way through the circuit. Once you press the A switch, see, it shorts it out. Or the B switch, shorts it out. Or both, shorts it out. Right here we have PLC programming. In this programming, we have addressed to push button 1, push button 2. We have normally closed push buttons. One push button here, one push button here. This PLC function is an examine if open logic function. Examine if open logic function. In other words, you ask yourself a simple question. Is the contact open? No, because we have a normally closed push button addressed to here. Same thing addressed to here. So they're both false. This is a false statement. This is also a false statement. Once you press the addressed push button to here, it opens and becomes true. But you also have to do the same thing for push button 2. It's a normally closed push button. Is the contact open? Once you press it, it opens up and it becomes true because this is an examine if open. Logic continuity goes through the true, all the way up to the pilot light, turning on the pilot light, similar to what we have here. Creating NOR logic gate using OR and NOT logic gates. This is the same as this, but instead we're using normally open push buttons. These are normally open push buttons, similar to this and this. Now, this is push button 3, addressed with a normally open push button. Push button 4, addressed with a normally open push button. The PLC function here is an examine if closed function. Once you close the push button, it becomes true, logic continuity goes through, closing this control relay. Same thing right here. If you, this is an examine if closed PLC instruction. Once it closes, this becomes true, logic continuity goes through here. So it has two different paths it can go. Once this becomes true, this is an examine if open PLC instruction. Once this closes, this will go false, turning off the PLC light, the pilot light number 2. In its present state, if you didn't push anything, it would be true, because you would ask yourself, is the contact open? Is this contact off? Yes. So that would be true, leaving on the lamp. And that's how to understand a NOR logic gate system.